Today's video will explain the test-driven development process. Hello, I'm James Helfrich. The test-driven development methodology was invented about 20 years ago for the purpose of decreasing the time between a bug was introduced and a bug was fixed, as well as a method to increase test coverage. This video will explain that test-driven development process. The test-driven development process starts with requirement solicitation. The second step is to write the test. The third step is to run the test. The fourth step is to write the code, and finally, we'll refactor the code we just wrote. Let's look at each of these steps in detail. So we're going to start by gathering requirements. We're going to do the requirement solicitation process, which could take a variety of different forms. We could do a formal requirement solicitation process, such as Royce described, which means interviewing all the clientele and carefully collating all the data and putting it into one big requirements document called requirement specification, or SRS. Or we could collect a bunch of user stories, or we could even have a product owner on hand. Whatever the deal is, we need to be able to gather the requirements in some format. Next, we're going to subdivide the requirements from something that are large and complex down to things that are more desirable. The goal is to get them down into bite-sized chunks, bite-sized being a few minutes of development work. So for an example, if I'm using user stories, I'm going to take an epic, which may be 2 or 3 weeks of development effort. I'm going to break it down to a large, and then a medium, and then finally a small, and maybe even a very small. A small might be 2 or 3 hours of development effort, but I'm going to subdivide it further than that. Next, I'm going to sort the requirements list from the easiest on top to the hardest on bottom, from the most isolated and the ones I can accomplish with the least amount of effort on top to the most interdependent, the most unknown, and most complex on the bottom. And we do this because we want to do the easy things first. Next, we're going to get the next requirement. And what do we do when the list is empty? Well, we stop, but if the list is not empty, then we're going to move on to step 2. Now, step 2 is to write the test. We're going to write a unit test or a collection of unit tests to exercise this particular requirement. Notice the code has not yet been written, so we're going to have to guess on the interfaces and on the functionality, but this is the way that the feature should work, the function or the method should work, rather than what it actually does because it hasn't done anything yet. Now we're going to run the test. Now, sometimes the code will fail to compile because I'm referring to a function or method that doesn't exist, but most of the time, the test will just plain fail. So what do we do if the test passes? Well, likely we have a defective test, or perhaps the test is not integrated properly into the project, in which case we have to write the test again until we get it right. Now, sometimes that feature happens to be already implemented. Well, that's a surprise. And if that's the case, that's awesome. Then go up and get the next requirement. But the vast majority of the time, that test will fail, and then we're going to move on to step 4. In step 4, I'm going to write the code for that test. Now I'm going to write the code, and does the test I just wrote pass? If the answer is no, then I'm going to go back and write the code again and again and again. Now the goal here is to write the minimal code necessary to make this test pass. And even if we know where the code writing is not complete, it's not handling important test cases or error conditions, it doesn't matter. At this point in time, we want the minimal code necessary to pass. We will create other unit tests to catch our error conditions and edge cases later. Now, of course, if it does pass, then we're going to want to create a backup of this particular bit of code here. We're going to create the backup, and then we're going to refactor the code. And here we're going to optimize on our software quality metrics. I'm talking algorithm efficiency or maintainability or configurable. I'm talking about cohesion or coupling. I'm talking about fidelity or convenience or abstraction or alignment. All the different software metrics we can think of, we're going to optimize on each one of those. And when we're finished, we are not done yet because we have to write that test. If the test fails, do not fix what we just broke. Instead, go back to our backup, undo whatever's necessary, and then refactor again. I promise you, your second time through, you'll do better than first. And it's a lot more fun and a lot more successful to rewrite code than it is to fix code we just broke. Now, after we refactor it and then the test passes, then we're going to go all the way back up to the process and get the next requirement, and we're going to go again and again and again. And we're going to keep doing this until the requirements list is empty. We've done everything they're supposed to do. Now, keep in mind that step 1A through 1D was accomplished with everything we know about the project currently, but there are unknowns. So after all the knowledge we gained through implementing these features and writing these unit tests and writing this code, all that understanding that we've gained is going to tell us we have more questions to ask. So we're going to go back up to the requirement solicitation phase and make sure we got everything we need to do. It might be that we finish implementing a dozen features or so. We go back to our product owner and we share with them the code they wrote, and they're like, okay, that's good for this sprint or for this milestone. Now we have some new requirements I didn't know I needed until now. So it's very important after we've emptied our list to go back and complete the requirement solicitation process again. But sometimes that last iteration worked and there is no more requirements to be had. That means every requirement we know about has been implemented and tested. We have 100% code coverage. All the code is high quality and all the functionality is there. At that point in time, and only at that point in time, are we finished. We can learn more about the test-driven development process in the test-driven chapter of the software design textbook.